Okay, so in this lesson, we're going to be looking at logarithmic transformations. So we looked at exponential, now we're going to get into logarithmic. So the general form of a log function is y equals log base b of x. So remember, that's how you pronounce it. So your base of your log is the same as your base of your exponential. It has to be greater than 0 and it cannot equal 1. So reviewing the same thing that we went over on the exponentials, if you have a base 2, this is what your parent function will look like, log base 2 of x. If you have a base 10, that's a common log. So your parent function is just log of x, and then base e is a natural log, which is ln x, so natural log of x. Okay, so the three different parent functions that we're going to be looking at are log base 2 of x, log of x, and natural log of x. So looking at our graphs, we're provided the graphs. Notice they all three look very similar. They all have a vertical asymptote, which is just like the three exponential. They all have a horizontal asymptote. So on these, this has a vertical asymptote. Notice it's approaching x equals 0. Notice it's the same for this one. And this one as well. So no matter the parent function for your log there, it's going to be the same. So the intercepts. So notice this first one is crossing the x-axis at 1, 0. Notice it is not crossing the y-axis, so there's not a y-intercept. Same thing on the next one. And also the third one. The domain, if you look at the x-axis, notice it's including everything greater than 0. Same on the next one. And same on that last one. And then the range, if you look, notice it's going down continuously, also going continuously up. So it's all real numbers for your range on all three of them. So remember, on the exponential, the domain was all real numbers every time, and then the range was y is greater than 0. Now it's the opposite because these are inverses, and log is an inverse of an exponential. So your range on all of them will be all real numbers. Your domain will change based on your transformations. Okay, let's look at the back. So we're going to be graphing these. We're first going to write down the transformations, and then we will plug it in the calculator and graph it. So notice we're starting with the natural log of x for our parent function. Notice inside parentheses, which is changing your x, is x minus 4. So anytime I'm changing my x, remember it's the opposite. So inside parentheses here, it would shift right 4. And then the plus 2 after the parentheses will go up 2. Okay, so we're going to type this into y equals on the calculator. So we need the natural log of x minus 4 plus 2. So the natural log button is the ln button. So natural log of x minus 4 in parentheses. So you're typing it in exactly as you see it on your paper. And then we need the plus 2. So you can graph it first if you want, just to kind of see what it's going to look like. Notice there's going to be a vertical asymptote. Notice this line here, so vertical asymptote would be here. So I'm going to go to my table. So second graph. We are starting with 4. So notice the error, that just means undefined. So we're going to fill those in on our notes. So when x is 4, it's undefined, which means it's not on the graph. 5 is 2. 6 is 2.6931. 7 is 3.0986. 3.3863, 3.6094, and 3.7918. Okay, so before we start graphing, let's talk about our vertical asymptote, because we know we'll have a vertical because this is a log function. So vertical, anytime you have a vertical asymptote, it will be shifting whenever you are going left and right. So notice we went right 4, and normally it's at 0, so now it's going to be at x equals 4. So I want you to go ahead and draw that vertical asymptote, so that way you know that you can't cross that line there. That's the reason when x is 4, it's undefined, because that is your asymptote. So we're going to graph 5, 2, 6, 2.693, 7, 3.09, 8, 3.38, 9, 3.6, and 10, 3.7. So make sure whenever you graph it, make sure there that it is approaching that vertical asymptote. So that vertical asymptote is now at x equals 4. The domain, if you look at the x-axis, is everything greater than 4. And then your range every time will be all real numbers for all logs. So it's very helpful if you can figure out your vertical asymptote before you start plotting your points, so that way you know where your points should be approaching, and you can also compare that with your calculator graph. Okay, looking at the next one. So this one we're starting with our parent function log base 2 of x, and we have, notice our new equation, we have a negative. That will be a reflection over the x-axis. Then notice in the very front, before our parent function log base 2 of x is a 2, which means there's going to be a vertical stretch by 2. Okay, so we're going to plug this into the calculator to find our points. Go to y equals, clear it out. So we're typing in negative, so negative 2, and then we need log, and we're having to change the base to 2. So we can't use just this log button on the calculator. We have to go to math. You can go up to make it faster. Go to A, so log base. We're changing the base to 2, and then we're taking log base 2 of x. So put an x there. So again, it should look like what you have on your paper. So then we can, if you want, look at the graph first. Notice this one is going down because there was a reflection. Okay, so let's go to the table. So second graph, we're starting with negative 1, and we're going to 5. So we're going to write these down on our notes. So when x is negative 1, it's undefined. 0 is also undefined. 1 is at 0, negative 2, negative 3.1699, negative 4, and negative 4.6439. Okay, so before we start graphing or plotting our points, let's think about where our vertical asymptote would be. So normally it's at x equals 0, which is a straight vertical line. So the only way it's ever going to change from our parent function is if it's shifting left or right. So notice in our transformations, it is not shifting left or right, which means it still needs to be at x equals 0. So go ahead and graph that. Which is why this, for sure, this one here is at 0 is undefined. This one because it's on the other side. So we're going to plot 1, 0, 2, negative 2, 3, negative 3.1, and then 4, negative 4, 5, negative 4.6. So again, it's helpful if you graph your asymptote, so that way you know where your line should be approaching. So I know my vertical asymptote is still at x equals 0. Domain is going to be x is greater than 0. Now notice, on exponential, whenever we were reflecting over the x, that changed our range to less than, but it's not going to be changing our x because when you reflect it, it's still on that right side because you're on this one, you're reflecting over the x-axis. So it's still x is greater than 0 here. The range is all real numbers. Okay, let's take a look at the back. Now, these should be pretty easy. We're going to write the transformations, determine domain range, and if there's an asymptote change. So notice we're starting with log base 2 of x. There's going to be a 5 in the very front, which means a vertical stretch. And then this inside parentheses is x minus 8, which means it's going to go right 8. Okay, so since it's going right 8, that's going to be changing my domain and also my asymptote. So right 8 would be x is greater than 8. My range will be all real numbers for any log function. The asymptote change, now it's at x equals 8 because you went right 8. Okay. Looking at the next one, we're starting with the parent function common log of x. So notice there's a negative in front, so that's a reflection over the x. Inside parentheses, there's an x plus 2, which would go left 2. And then the minus 4 goes down 4. Since there is a horizontal shift, domain will change, asymptote will change. Left 2 means my x values will be greater than negative 2. The range will be all real numbers. My vertical asymptote will now be at x equals negative 2. Okay, third example, notice we're starting with natural log of x. So looking in the front, that would be a vertical compression, because that's in between 0 and 1, by 4/9. Notice that there's no parentheses with your x, so there's no horizontal shift, but there is a plus 6 with no parentheses, so that's going to be going up 6. Since there is not a vertical shift, that means domain will stay the same, so x is greater than 0, and your asymptote will also stay the same. Okay, next part, last part. Now we're given the transformations. We're going to come up with our equation. So make sure you're really focusing on what you're starting with. So this one, our parent function is natural log of x, where we're going to reflect it over the x. Go to the right 5 and 15 down. So start with g of x equals. Reflection is a negative in front. I know I'm going to have natural log of x. Since I'm going right, I need parentheses, and I need to do the opposite and subtract 5. And then down 15 would be minus 15. Since I'm going right, it changes my domain and my vertical asymptote. We're going right, so that would be x is greater than 5. All real numbers for range, and your vertical asymptote would be x equals 5. Okay, so B. Starting with log base 2 of x, it's reflected over the x, vertically compressed by 1/2 and up 1. So the negative is the reflection. Vertically compressed means that number needs to go in the front of your log. And I have a log base 2 of x because that's my original. Since I don't have a horizontal shift, I don't need parentheses, and then I need to add 1 because I'm going up 1. Since there's no horizontal shift, my domain will stay as x is greater than 0. And my range will be all real numbers. I keep writing y there. So my vertical asymptote will stay at x equals 0. All right, last one. Starting with common log of x, vertically stretched by 8 and up 10. So vertically stretched, that means that 8 needs to go in front. I have common log base 10 of x. There's no base there. And since there's no horizontal shift, no parentheses, but I need a plus 10 because I'm going up 10. Since there's no horizontal shift, x is greater than 0 for your domain, all real numbers, and that vertical asymptote stays at x equals 0. Okay, so this is transformations of logs. Let me know if you have any questions.